Okay, so let's talk about these four stream transportation types in a little bit more detail. So the solution is going to carry the smallest material. We're talking at the molecular level. So what's happening here is that material is being dissolved, and that dissolved material then becomes part of the water itself. So it flows within the water, and it really isn't detectable by the naked eye. You might get some color change if you've got the right tools to measure, but you're not going to notice it otherwise. In this case, think of, a sugar cube dropped in a cup of coffee or some tea or water, for that matter. Stir it in. There's no evidence of the sugar cube anymore until you taste the water. And that's where the sugar is. It's dissolved within the liquid itself. All right. So there are minerals that dissolve when in contact with water, and then that mineral then becomes part of the transported water in solution form. Suspended load is small particles of rock, silt, for instance, very, very fine grained material that is suspended. It floats within the body of the river. This is the stuff you see. This is the muddy Mississippi bit, right? This is that cloudy Mahoning River. Is what you're looking at is all of that stuff in the river that's moving alongside the water. It's moving with the water from the bottom of the river bed all the way through to the top. All right. It only falls out of the river when the river stops flowing. The velocity has to be at or near zero. Bed load is then the material gets a little bit larger in size. This material is too big to be carried in the stream proper. It gets moved along the bottom of the river, and it gets moved by a couple of different ways. Either traction, where what's happening, just like that line that we were talking about before, where you're getting pushed from behind, where the place that you're getting pushed from behind is a high pressure zone, and the area right in front of your toes is a low pressure zone. That low pressure zone acts like a little bit of a vacuum. So what happens is the rock or the pebble or the stone gets sucked like a vacuum into the little low pressure zone, and it's established there until enough pressure is built up on the backside of that rock to create a low pressure zone and a high pressure zone, and then it moves by traction again. All right. The second mechanism is something called siltation, a whole lot like playing pool, where you've got one cue ball hits another ball, a stripe or a solid, and that solid or stripe then is moved under its own velocity. So if you've got a bit of rock that is in suspension, or it itself has saltated, it hits another rock, it's going to transfer its energy to that other rock and cause it to skip across in a parabolic curve up and over, and then as it comes down, its trajectory will hit another rock or a pebble or a stone and cause that stone to then skip through. So we're rolling and we're bouncing pebbles by interacting with each other, enhanced by the direction of the river and the velocity that that river is carried. All right. These saltating and traction mechanisms can become suspended load if the velocity is large enough. All right. So in this diagram, then we've got a illustration of all of the different mechanisms that we have. So the solution material you can't see. Suspended load are all these tiny little particles that are moving along in this channel right from the bed all the way to the top. With bed load is everything that's moving along the bottom, and it can be moved by being dragged and rolled, or it can skip. So here's saltation, right? Where I've got a parabolic curve happening here. Here's the stone that's up and moving forward. It's going to come down. It's going to hit this little stone. This little stone's going to come up and bounce and hit another little stone, and this little stone's going to come up and bounce. All right, so this is what we end up getting as a function of how material is transported through a river.